Hello guys, I'll be doing the chemistry quiz, not chemistry quiz, chemistry revision sheet for the finals. Okay, isotopes. Isotopes have the same protons or same mass atomic number, but different mass number, different nucleons, different not protons, different neutrons. Okay. Do they have the same mass number? No, they do not. Do they have the same atomic number? Yes, they do. Let's check the second condition. Do they have different mass numbers? That's true. Same number of neutrons? Wrong. Same number of electrons? Correct. Different number of protons? Wrong. So only B is correct. Okay. The number on the bottom is the atomic number, and the number at the top is mass number. So atomic number is the one that's down. Mass number, the one that's up. Which of the following is true about deuterium? I don't know how to pronounce it, but okay. Deuterium, what you need to know is that it's an isotope of hydrogen, in which here you have the nucleus, there is one proton and one neutron. Okay? So that means that the mass number will be 2. So it's an isotope of hydrogen. It is an atom containing one proton and one neutron. It is given as H2 because deuterium is called H2. 2 represents the mass number, and it has the same atomic number as H11. H11 is another isotope of hydrogen. Okay? But in this case, you have only one proton. You don't have any neutrons. That means that the mass number is 1, which is the same as the atomic number. Therefore, meaning that there are absolutely 0 neutrons. But they're both different isotopes, but they're of the same element. And different isotopes of the same element still have the same atomic number, or they still have the same protons. Number 6 and number 7. They're both questions that you should memorize. Which of the following affects how an atom reacts with other atoms? Okay. So, just so you can know, how can atoms react with each other? It's based on the charge. Okay, that's what you need to know. Now, the explanation is given. The explanation is the following. It's because, for example, you have Na plus and Cl minus. These two, they bond together to form NaCl, an ionic compound. So basically, they bond together because their charges are corresponding. One is positive, one is negative. So based on these two charges, based on their charges, okay, they bond together or they react with each other. So what affects the reaction is the charge. And why do we say also number of electrons? Since the number of electrons is what determines the charge. So Na plus is because there is one less electron than the number of protons. Okay? So that means that it's also the amount of electrons. Here in Cl, because there's one more electron than the number of protons. So that's why it's negative. Okay? So yeah, it's based on the number of electrons, which makes it due to the reason of the charges. Not because there's the number of neutrons in the nucleus. This is false. Okay? Now, a nucleus is stable when they said nucleus, so we can immediately eliminate some options when they're nothing related to nuclei. So protons and neutrons are related to nuclei. Protons and electrons are not. Protons are related, but electrons aren't. So therefore, eliminating this whole option. Electrons and neutrons. Electrons are not. Neutrons are, but we still eliminate the option. Light mass. What on earth does a light mass have to do with being stable? What does it have to do? Okay? Or now that we have these 3 options, we can instantly eliminate light mass, because that doesn't make sense at all. And equal number of protons and neutrons. Think about it. Think outside of the box. You should memorize it, but think. How can the number of protons and neutrons, being equal, their congruence or their equality, it does not affect a nucleus's stability. Okay? It doesn't affect a nucleus stability. What affects a nucleus being stable is its ability or capability of existing indefinitely. That means that since stable atoms, they do not react with each other, they stay alone, they don't live all together, they're just nomads, they stay alone, they exist indefinitely. Okay, now number 8, the rule for average mass. The rule is percentage multiplied by the mass number plus whatever. So you could say it as the percentage times the mass number, the sum of them, if they are given. Okay, so we have the percentage 65%, 65 over 100, multiplied by the mass number of the first isotope is 39. So we put 39 here, and then we add it to the other given, 35 over 100 multiplied by 40, which is the mass number. Plug it into the calculator, you will get 39.35. Rounded to one decimal place, you will get 39.4. An ion of sodium has 11 protons and 10 electrons. The charge of the nucleus. What is there in the nucleus? There's neutrons and protons. Neutrons have they're neutral, so their charge is 0. Okay, their charge is 0. Okay, but protons, they do have a charge. It's a positive charge. So basically, what factors determine the charge of the nucleus? What's the answer? The charge of the protons. So if there are 11 protons, what's the charge of the protons? Positive 11. Since there's one charge per one proton, so it's 11, and positive, since protons are positive. So positive 11 is the answer. But now in this part, they're asking us for the whole ion or the whole atom. The whole ion is the difference between the number of protons and the number of electrons. So the number of protons is 11 and the number of electrons is 10. So what's the difference between these two? The answer is 1. Now, how do we know if we put a positive or a negative? It's based on which one is the biggest. Which one is bigger, protons or electrons? Here it's protons, since there's more protons than electrons. So the protons outnumber the electrons, and the answer is positive 1. Which of the following subatomic particles determine the size of an atom? Okay, let's visualize this. We have this atom. This is the nucleus, okay? Here are the protons and the neutrons, and then we have the electrons here. They're scattered all over the electron cloud, okay? And then here we have another nucleus with the protons and the neutrons, and then here we have the electrons. Okay, now what we can do is draw a boundary around the atom. Which atom can you observe is bigger? Obviously this one, right? It's way bigger than this atom, right? So therefore, what can you say affects the size of an atom? The number of electrons. So the answer is C, the number of electrons. Which of the following is false regarding helium? Okay, helium has 2 neutrons, 2 protons, and 2 electrons. It's true. Open the periodic table, you will notice that helium has 2 protons, therefore making it have 2 electrons, neutral, and 2 neutrons. 2 protons, 2 electrons, and 2 neutrons. The charge on a helium nucleus is positive 2. Yes, because the nucleus has neutrons and protons. Neutrons are neutral, and protons, protons are the dependent factors of the charge of the nucleus, so it will be positive 2. The charge of a helium atom, not the nucleus, the whole atom as a whole, it's the difference between the electrons and the protons. So between 2 and 2, it's 0. So this is a correct one. The mass of a helium atom is 4 times the one of a hydrogen. This is true, but let's visualize it. The mass number of a helium atom. What's the mass number of helium? You have 2 protons and 2 neutrons, so 2 plus 2 is 4. What's the mass number of a hydrogen atom, hydrogen 1. Hydrogen 1, that means that there's only one proton, there is no neutron. Okay, so 1 proton plus 0 neutrons is 1 mass number, so it's 1. So between the mass of a helium and hydrogen 1, it's 4 times. Okay, so the helium is 4 times that of the hydrogen 1. Now, helium has 0 nuclear charge. This is false. Helium does not have a nuclear charge. Okay, although the charge of the helium atom is 0, doesn't mean that its nuclear charge is 0. Okay, given the isotope of this atom, fluorine, give the number of protons, neutrons, and electrons. Protons is the atomic number, which is 9. Neutrons is the mass number, which is 19 on the top, minus the atomic number, or minus the protons, which is 9. And the answer you will get is 10. Now, what's the number of electrons? Here it's neutral, there is no charge. So the number of electrons is the same as the number of protons. So it would be 9, 10, 9. Given this oxygen atom, or here it's a charged ion, it's an anion, give protons, neutrons, electrons. What's the protons? It's 8. It's the number on the bottom, the atomic number. What's the neutrons? It's 16 minus 8, the mass number minus the atomic number / protons. 16 minus 8, which is 8. And then they want the electrons. The electrons are the same as the protons, but you add or subtract with the charge. Okay, so since there's 2 minus, that means that there are 2 more electrons than protons. So it's the number of protons, which is, so it's the number of, my bad. Wait, I need to reopen it. Anyways, the electrons is the number of protons plus or minus the charge. Okay, the number of protons was 8. Okay, where is it? Okay, the number of protons was 8. So then it will be plus 2, since there's 2 more electrons. So 8 plus 2 will be 10. So the answer is 8, 8, 10. Given this of bromine, the atomic number is the one that's at the bottom, which is 35, and the mass number is the one that's at the top, which is 24. The number of electrons in this lead isotope is, the number of electrons is the number of protons plus or minus the charge. What's the number of protons? It's 82. And then plus or minus, here we have 2 more protons than electrons according to the charge. It's positive, so there are more protons than electrons. So we do 82 minus, what's the charge? 2. So 82 minus 2 is 80. Which of the following is the correct balanced equation? The dissociation of calcium bromide. So we have Ca, 2 plus, that's the sign of calcium, it's in group 2. Plus Br minus, it's in group 7. And don't forget the sign, the number of bromide. We don't put it at the bottom, we put it as a coefficient, okay? So this is the answer, this is the correct one. Here they put it as a subscript, which is wrong. You should not add it as a subscript, you should add it as a coefficient. And here they added it as a charge. Who gave you the it's not as a charge, it's either as a coefficient or a subscript, and it's obviously not a subscript, it's a coefficient. As the atomic number of the noble gases increases, their increases. Where the atomic number increases, you go down the group, okay? And when you go down the group in noble gases, the melting point will increase, the boiling point will increase, and the radius of the atom will also increase. This is to be memorized, okay? Which of the following is false about lithium, sodium, potassium? This is cesium, but I forgot what's this one. I think rubium, I'm not sure. And francium. You can tell that these are the group 1 elements, which are alkali metals. Okay? We need to choose the false one. In nature, they exist as pure metals. This is false, so we choose it. Why is it false? Elements in group 1 are highly reactive, meaning that they like to mix with other elements. Therefore, you can never see it in nature being alone. You will always see it stuck together. So you can never see it being pure. You will always see it being mixed with something else. They are soft and shiny solids, which is true. They're called alkali, which is true. They have one more electron than noble gas, which is true. Okay, what's stopping alkali metals from being noble gases is the fact that they have one more electron. Okay, they have one more electron than noble gases. This you should memorize it. Alkali metals in the pure state have one more electron than noble gases. But when they react, or not when they react to form stable gases, or when they react to form like ionic compounds, for example, Na plus reacts with, for example, Cl minus, okay, it gives the electron here, it donates it, so it loses the electron, so Na becomes Na1 plus, or just simply Na plus, and Cl minus. And when it does so, when it loses the electron, that's when it finally achieves noble gas configuration, when it forms the ionic compounds, or when they form stable ions with +1 ions. The elements, okay, this is the first 3 elements in group 1. They have similar chemistry. These elements have high melting points. This one is kind of true. These 3 elements, they do have high melting points, okay? As the melting point in the group 1, it's different than the noble gases. It actually decreases down the group. So the elements at the top of the group, they have the highest melting and boiling point. But what's stopping this from being true is that they don't all have the same melting points. Lithium has a really high melting point compared to sodium and potassium. So although they all 3 have high melting points, they don't have they don't have similar high melting points, and compared to some other elements, they have lower melting points. Okay, this is why we don't say relatively, because they have like lower melting points than other elements in the periodic table. They are able to form -3 ions. This is totally wrong. They form stable +1 ions, not even negative. The moment you say negative, wrong. The moment you see 3, wrong. They're way off. So it's +1 ions. And they are malleable and they can be cut by a knife. Which of the following is true about the group 1 element, or the alkali? In nature, they exist as pure metals. It's false. You will always see them mixed together. Each has one more electron than the noble gas. This is true, that the alkali metals have one more electron than the noble gases, but when they react to form stable ionic compounds, or just stable compounds in general, they lose the electron and their charge becomes 1+, and they achieve noble gas configuration, or noble gas electron arrangement. Which of the following are about metals is true? They are brittle, it's false. They are luster or shiny, it's true. And they are poor conductors, it's false. This is things you should know from grade 3 or 2. Which of the following statements about alkali metals or their ions is true? Each of the neutral alkali metals has one more than the nearest noble gas. This is true. Alkali metals have one more electron than the noble gases, but when they react with other elements, they lose this electron, and their charge becomes 1+ or +1, and they achieve noble gas configuration. But when they form ions, here we talk about neutral alkali metals, okay? We talk about the neutral ones in their pure form. They have one more electron, but when they form ions, that means that when they have a charge, they achieve +1 ions, and then they have the same number of electrons as the nearest noble gas, achieving noble gas configuration. But so when we say they achieve noble gas configuration, that means that they achieve noble gas electron arrangement. And when they achieve noble gas electron arrangement, that means that they have the same number of electrons as the nearest noble gas. A compound is said to be stable if it has low potential energy. This is true. The less energy, the more stable. Not any type of energy, specifically potential energy. High kinetic energy, no. Especially not high. Transition metals, no. What does that have to do? Colored, no. High molecular mass, of course not. Transition metals is related to being colored, but they're both not true. What does it have to do if you have to have a high molecular mass? That does not necessarily have to be true. You can have a low molecular mass and you can be stable. Okay? So it's more about living indefinitely and low potential energy to be stable. As we go down the group, as we go down the group for alkali metals, that means that we increase atomic number. And that means that we decrease melting point, we decrease boiling point, and this is what we go down the group. Increase atomic number, decrease melting point, decrease boiling point. Which of the following is true regarding the first group? They have one more electrons than a noble gas. It's true. I don't need to explain it again. They exist as pure metals. It's false. They are mixing together, and they are soft and shiny. Which statements regarding the stability of sodium chloride is true? By losing an electron, Cl. Wrong. Cl doesn't lose an electron. It gains an electron. So this is immediately false. By gaining an electron, sodium does not gain electrons, it loses electrons. So this is immediately false. NaCl is stable because it is made of oppositely charged ions with similar electronic structure, such as the adjacent noble gases. Yes, they are formed by oppositely charged ions. Okay, so the last part is true. Calcium and bromine react to form the salt calcium bromide. Which of the following equations is/are true? Okay. Calcium, it's when calcium gains an electron. Calcium does not gain an electron, and plus it's wrong, this statement. Okay, the second one, bromide, or here it's bromine, bromine, whatever. It gains an electron, okay? And by gaining an electron, it becomes an anion, Br minus, and in the process, it loses energy, okay? Because when you gain an electron, it's an exothermic reaction, which releases energy. It does not absorb the energy, it releases the energy. When it becomes an anion, Ca plus 2 Br minus is equal to Ca Br2. Plus energy? No. Okay, this is false. They're giving us the whole equation, but in this case it's a false equation because it's, first of all, it's Ca2 plus, not Ca plus, so that's a mistake. Which of the following is not a physical property? They are soft metals and can be easily cut with a knife. This is a physical property, okay? They conduct electricity. This is a physical property. They are malleable and ductile. This is a physical property. Low density is a physical property. And they react vigorously with water. It's not a physical property. But you tell me, don't alkali metals, they actually do react with water? Yes, they actually do. But this is not a physical property. It's a chemical property. So don't confuse yourself between chemical and physical properties. Elements of what group form -1 ions? We know that it's the halogens or group 7 or 17, the same thing. They form -1 ions. For example, an example of this is chlorine, bromine, fluorine, tennessine, whatever you pronounce it. These are in group 7 and they form -1 ions. Which of the following is true regarding elements of group 6? Group 6 is the one that's before group 7. And group 7 is -1. So group 6 is -2. Okay? So they form -2 charge, not +2. They react with non-metals by sharing 2 valence electrons. This is true. By sharing 6 valence electrons is false. Here, why do we say sharing? It's because it's between a non-metal and a non-metal. And between two non-metals, they share. They don't lose, they don't gain. They share their electrons. Which of the following is false regarding metals? Okay. Metals, they have some electrons that are extremely immobile. That are extremely mobile, not immobile. This is a true statement, as the electrons in the crystal lattice, okay, they like to move between the crystal lattice, okay? So electrons, they're the ones that they move freely, okay? They belong to the lower left of the corner of the periodic table. So in the periodic table, okay, trying my best to draw it. Actually, they're shown on the left of the periodic table. This is the metals, okay, except for hydrogen. They are found to the left. I don't know why they said left corner, but anyways, on the left corner, it's still true. These are still metals here. They have a shiny appearance. It's true. They call it luster. And they combine with other elements by losing electrons. It's true. For example, a very famous metal is sodium. And it's known for having a charge of 1. Since it's an alkali metal, it has a charge of 1 plus. And it loses an electron. That's why it has a charge of 1 plus. Okay. Which of the following elements are liquid at RTP? We know that liquid that are metal at RTP is mercury. But between these three, okay, sulfur is actually a solid. It's a yellow solid at RTP. Lead is a solid at RTP. Bromine is it's actually a liquid at RTP. It's not a solid. It's like I'm pretty sure it's like a brown, I think, or a blue. I forgot the exact color, but it's a liquid at RTP. Most important thing you should know. Which of the following is true about noble gases? They don't have high boiling point, like relatively high. They don't. They exist as diatomic is wrong. They exist as monoatomic. Okay. They don't mix with each other, and they are unreactive, meaning that they are stable. Okay, cesium nitride. The charge is CS plus N3 minus. Crisscross, it's CS3N. This one, it's Mg2 plus P3 minus. Crisscross, you get Mg3P2. You get these from the periodic table. You get the charges from the periodic table. Li plus S2 minus. Crisscross becomes Li2S. Ca2 plus F minus. Crisscross CaF2. Get the charges from the periodic table. Okay. Element X is found to the right of element F. Okay. So we have an element X, and it's found to the right of element F. Element F and this element X is found to the right. And the atomic number of F is 9. They gave it to you, and the mass number is 19. X has 13 neutrons. They want the protons and the neutrons. When you go from period, like from one element from a period to another period, it increments by 1, plus 1, plus 1, plus 1. Okay? So if this one is 9, then this one, the next one is 10. Okay, so X, now we know that it has atomic number 10. Now the mass number, we find it by doing the protons plus the neutrons. What's the protons? We know now it's 10, and the neutrons is 13. So 13 plus 10 is 23. Now element X is found to the left of argon. And the atomic number of argon is 18, and the mass number is 40. This one has 20 neutrons. 20 neutrons, okay? We need to find the protons. If this protons is 18, the one to the left, it decreases by 1, so it's 17, and the mass number is the neutrons, which is 20, plus the protons, so 20 plus 17 is 37. Sample of carbon contains 70%. Okay, this is the same rule. it's the same exact rule. You do the percentage multiplied by the mass number. So let's do it ourselves. It's 70 over 100 multiplied by 12, the mass number, plus 20 over 100 multiplied by 13 plus 10 over 100 multiplied by 14, and you will get 12.4 on the calculator, which is the average mass. Okay, here they gave us two isotopes, this one and this one. They gave us the average mass. They want us to find the percentage abundance. How do we do this? Okay, we have the percentage here, but we need to find it. Let's say it's x, okay? And we multiply it by the mass number, which is 24. And here we have the other one over 100. If this one is x and the total is 100 and we only have two isotopes, then it's 100 minus x. Okay, 100 minus x. And this one we multiply it by 25. And we make it all equal to 24.6. Plug this into the calculator and you will get x is equal to 40. So 40% for this isotope. And for this isotope, you do 100 minus 40, which will get you 60%. Okay. Now, a sample of gallium is found to consist of 3 isotopes. Okay, they gave you the percentage of one isotope, and they gave you the average one. Okay. The same exact thing, over 100. But this, okay, x over 100 multiplied by 69, and then you add it to the, they gave you that the 70 is 10%, so 10 over 100 multiplied by 70 plus this one over 100. What? Think about something. This one, do you do 100 minus x? No, you do not. You've already taken out 10. Here you've already taken out 10. So if you take 10 out of 100, so 100 minus 10, you will get 90%. So here you do 90, just 90? No, you do 90 minus x. Okay? Since now that you've taken out the 10, you're left with 90 and x. So if this is x and this is 10, this will be 90 minus x. You've taken out 10 already. So now the basis is 90. And then you multiply it by 71 and you put it all equal to 70.5. Plug it into the calculator. You will get x is equal to 20%. So 20% for the first isotope, the second isotope is given, and the third isotope is not 100 minus 20, it's 90 minus 20, which will get you 70% for the third isotope. Now, you have two isotopes of silicon, and they gave you the symbol. So this is the protons, the same as the atomic number. They're both gonna be 14, and the neutrons, they're gonna be the mass number, which is 28, minus the proton, which is 14. And the second one, it's 29 minus 14. So here you get 14 and here 15. And the electron is gonna be the same as the proton, since they didn't mention any charge. Okay, the average atomic mass of silicon is 28.1. Find the abundance of each isotope. So you have here the two isotopes of silicon, so it's x over 100. Remember, you have just two, so it's just x over 100 multiplied by 28, added to 100 minus x over 100 multiplied by 29, and you get 28.1. Plug it into the calculator. You will get x is equal to 90%. So 90% for the first isotope, and then you do 100 minus 90, and you will get 10% for the second isotope. A sample of bromine contains two isotopes. The average mass of one of the samples, okay, it's just the same one, there's no trick. X over 100 multiplied by 79 plus 100 minus x over 100 multiplied by 81, and you will get that, and you put it equal to 79.8. Plug it into the calculator. You will get x is equal to 60 So this is the answer for the first isotope, and then you do 100 minus 60 to get 40 for the second isotope. Now, finish the table below. The atomic number will be the same as the protons, and since here there's no charge, and means the protons will be the same as the electrons, and since the neutrons is 11, you do 11 plus 10, 11 neutrons plus 10 protons to get 21 as the mass number. 8 atomic, okay, what they gave you is 9 neutrons and 17 mass number. So 17 minus 9 will get you 8 as the protons. And protons will be the same as the atomic number, which is going to be 8. They're both 8. And now, since there's no charge, the electrons is also going to be 8. Now, they gave you protons, which is 16, and mass number. So 31 minus 16 to get the number of neutrons, which will get you 15. And since the protons are the same as the atomic number, they're just going to copy the same number. And the electrons is the same as the protons, but you plus minus the charge. What's the charge? It's 2 minus. So it's the number of protons plus 2, since there are 2 more electrons than the protons. So there's going to be 18 electrons in total. And then you have copper, 29 atomic number, going to be the same as the protons. And then the neutrons, you have them here. You add 34 plus 29 to get the mass number 63. And then the electrons is still going to be the same as the protons, plus minus the charge. The protons is 29 and the charge is 2 plus. That means that there are 2 more protons than the number of electrons. So 29 minus 2, and then you will get 27 as the number of electrons, since there are 2 less electrons than the number of protons. Barium is 56. You're going to get the same protons as the atomic number. Neutrons is 81, so you do 81 plus 56 to get the mass number. And then you're left with the electrons, which is, again, I repeat, the protons plus minus the charge. The protons is 56. And then here we said that here they gave us that there is 2 plus barium. That means that there are 2 more protons than electrons. So we do 56 minus 2, which will get you 54. If you don't understand the 2 more, the 2 minus, the 1 more, the 1 minus, if you see a charge of plus, you do minus. If you see a charge of minus, you do plus. And this you do it to the protons. So if you see a charge that says minus, you take the protons and you do plus. If you see a sign that says plus, you take the protons and then you do minus. Okay, so you do the opposite technically. As3 minus, they gave you the electrons and they gave you the mass number. To find the electrons, you can find the protons, but in this case, the minus, the plus method does not work because you're not applying it to the protons. The plus minus method, the inverse plus minus method, only works if you're applying it to the protons. Now, in this case, if you're applying it to the electrons, it's not gonna be the inverse. It's gonna be the same. So since they're 3 minus, it's gonna be 36 minus 3. Okay. So if you apply to the protons, you're gonna do the inverse. If you apply to the electrons, you're gonna do the same. So 36 minus 3, you're gonna get 33, and then 33 protons, you're gonna get 33 atomic number, since they're the same. The mass number, you get 75. So 75 minus 33. So the mass number minus the proton to get the number of neutrons, which is 42. This was a long exercise, but it's easy and 3 marks. What is found in a diamond? Carbon. Diamond is a network solid made of carbon atoms together. Another type of a network solid is graphite. Graphite is a network solid, and it's also again made of carbon. A liquid metal at room temperature, we all know mercury. Non-reactive gas, you can choose any noble gas. You open the periodic table, just choose any random noble gas you see. Here they chose helium, but you can choose any. And the least dense alkali metal is the first alkali metal, which is lithium. You should memorize this, okay? The last one is to be memorized. Since the first 3, they're logical. We know them since we were small. But the last one is, maybe it's a bit tricky if you don't know it yet. But the least dense alkali metal is lithium. Okay, which one is endothermic or exothermic? Okay, think about it as a magnet. When you add South Pole and South Pole, they repel each other. Okay, so there's no need for you to add energy to separate them. When you do North Pole, North Pole, they instantly repel each other. So there's no need to add energy to separate them. when there's North Pole or South Pole, or South Pole and North Pole, they go to each other, so they attract. So to separate these two, you need to add energy to the system. So electron and electron, they're both negative, so they will repel. So there's no need to add energy to the system, therefore making it release energy, not absorb energy, so it's exothermic. Separating an electron from a proton, they both have opposite charges. That means that they attract each other, so you need to add energy to the system to separate them. Proton and proton, same charge, they will repel each other, no need to add energy, making it exothermic. Electron from a neutral. In a neutral atom, you will still find protons. So that means that the electron will naturally attract to the protons. Okay, doesn't matter if they say neutral, there's still protons existing in the atom. So it's gonna stick together and they're gonna attract each other. So they need energy to separate them. So it's gonna be endothermic. Electron from positive, so it's negative to a positive, they're gonna attract each other, making it exothermic, so you can absorb energy to release the two subatomic particles, or from the subatomic particles to the atom. Okay, give 2 pieces of information regarding transition metals. The 2 most important things you need to know about transition metals. Don't take it as work, take it as a fun fact, is that they form colored compounds when they react, and they form ions of opposite charges. Not opposite charges, they form ions of different charges, I mean. Okay, this is to be memorized. Take it as a fun fact, okay? Consider the following isotope of sulfur. How many protons are there in the sulfur atom? There's 16. Okay, it doesn't matter. How many electrons? It's gonna be the protons, okay? Plus minus the charge. So it's gonna be 16 plus, since the charge is negative, you're gonna do plus 2, which will get you 18 as the electrons. Neutrons is gonna be the mass number minus the atomic number. So 33 minus 16, which is 17. And the mass number is just the number on the top, and the atomic number is the number that's at the bottom. Okay. Okay, we have 2 more pages. Okay. The atomic number is 13, so the protons is going to be the same as the atomic number. And they gave you the neutrons, which is 14. So to find the mass number, you do 14 plus 13, which will get you 27. Now, the number of electrons is the same as the number of protons, but since here it's positive, that means you do 13 minus 1, which will get you 12. Okay, they gave you the number of electrons and mass number. Electrons here is 9. Here it's minus 2. Remember, for the electrons, you copy paste. So it's 9 minus 2, which will get you 7. Since the protons is 7, it's also going to be 7 atomic number. And since you already have the protons, you do the mass number minus the protons, which will get you the mass number, which is 8. Use the atomic table. Use the periodic table. Which word describes the substances found in the periodic table? They're called elements. The substances in a periodic table, they're arranged in order of increasing atomic number. Like in a period, they increment the atomic number by 1. So if this atomic number is here, it's 2, then this is 3, 4, 5, 6, 7. Okay, it increments by 1. Okay, here you have a light bulb, and you have the filament made of tungsten, and you have argon gas. Okay, they ask you, why is the gas that they put argon, not any other gas? And the main reason for this is because argon is a noble gas, okay? And since argon is a noble gases are known for being stable, okay? And they're known for being unreactive. So this is what you can put as the options, okay? Unreactive, so they don't react with tungsten, and they're stable. Inert means stable, okay? They're the same thing. Okay. Here they gave you this atom. Name the particle labeled E. This is an electron, since it's in the cloud. You see this orbit here? It's it's actually not how real atoms look like, but it's just a diagram to help you understand. These particles are E, or electrons. F is the nucleus. This whole thing is the nucleus. And the two subatomic particles that are found in the nucleus are the protons and the neutrons. Okay? Collectively known as nucleons. Cobalt is the transition metal. Potassium in group 1 is in the periodic table. Okay. They say that they want two things, physical properties that are similar between cobalt and potassium. This is just a fancier way of saying, give me a physical property of metals. It's the same thing as saying, name any physical properties of a metal. It's just a fancier way of saying it to make you think a bit more. So here you just say one physical property of a metal. When a small piece of potassium is added to cold water, potassium floats and disappears when it reacts. Give two other observations when made when a small piece of potassium is added to cold water. Personally, I don't like the first and the second option because they're basically repetition from what was stated in the question. I really like the second and the fourth option because I feel like they're a guarantee for full mark if this comes written. When you add an alkali metal or potassium or lithium or sodium, when you add it in water, or just general alkali metals, when you add them in water, they react vigorously. In water or air, they react so violently, so vigorously, okay? In the water, they even react way stronger, way faster, okay? So what will this cause? When you put potassium in water, it's known to produce a flame. What color of a flame? Lilac or purple. Lithium and sodium produce other colors. Okay, they produce the respective colors, but potassium produces a purple or a lilac flame, and it also produces effervescence. Effervescence means the fizziness or bubbles. When you open a soda can, for example, this bubbles it's carbonated. It's called effervescence. Okay, or fizziness or the bubbles. Okay. And these bubbles that are released, this is called carbonated, but here in this case of the potassium added in cold water, I think, if I'm not mistaken, it's hydrogen that is released. What is meant by atomic number? It's a number of protons. Elements in the same group of the periodic table have similar chemical properties. It's used to memorize that in the same group or the same column. These elements right here, they have the similar chemical properties. Okay, memorize it. Similar chemical properties. Okay. Here they show an atom. They want the atomic number of the atom. Atomic number is the number of protons. And here we have the key. It's the one that's unfilled. So 1, 2, 3. Three protons, or atomic number 3. Mass number is the number of protons and the neutrons. So we just count the subatomic in the nucleus. 2, 3, 4, 5, 6, 7. 7 of them, which is correct. Number of protons in an isotope of this element. Protons is the number of atomic number, which is 3, 3. Okay. Group where this element is found. You open the periodic table and you find in which group can you find an element with atomic number 3. You look in the periodic table, okay, like this. You look at it and it's lithium, okay, atomic number of 3. Okay, now number 50. Here there is 0 charged particles. Here you have, okay, you have a charge of 0. That means that the number of electrons will be the same as the number of protons and the neutrons given. So if there's 11 protons, that means there will be 11 electrons. If there's 18 electrons, that means there will be 18 protons. Here, we have to determine the charge. So here we have one more electron than protons. That means that it's -1, since there's more electrons than protons. So 1, and the charge will be minus, since there's more electrons than protons. So it will be -1, the charge. And now they ask us to give us 2 particles from the table. that are isotopes of each other. Isotopes of each other, it means that they will have the same atomic number, but different mass number. But just most importantly, we need to find something with the same atomic number or same protons. It's A and B. They have the same atomic number. Okay, element Z is in the same as A, less reactive than A. Okay, so the same group as A. Okay, so it's in the same column as A, and if you see here we have hydrogen. Okay, fine, whatever. You open the periodic table. I don't have the periodic table with me, but I will draw you the column. You have this group, and you find on this group you will have sodium, which is 11, atomic number of 11. They want the one that's less reactive than, but it's in the same group. What element are they talking about? Lithium, because lithium is above sodium. It's in the same group, so they have similar chemical properties, okay? Same group, but it's less reactive, okay? Comment on the reactivity of C and explain your answer. C, okay, if you open the periodic table, there's a group here, and you will find that atomic number 18 will be argon, and argon is in the last group of the periodic table, making it a noble gas. And noble gases are unreactive, or they're called unstable, or they're called stable. Not unstable, I mean they're stable. They're unreactively stable. Okay. State two physical properties of group 1 elements of similar transition methods. I repeat that this is a fancier term of saying what are the physical properties, or what are the physical properties of metals. It's just a fancy way of saying just state any. They're shiny, conductors, malleable, ductile, okay? Two ways in which group 1 are different from transition, or transition is different from group 1. Transition, they form colored compounds, they form ions of different charges, they have greater densities. Group 1 have lower melting points. This one you should memorize it, okay? Memorize, okay? Part 2, we didn't really do it in class, but we should just know that when there's effervescence, or when you add alkali metals like sodium, lithium, potassium, etc., when you add these in the water, they will have an effect of effervescence, and as I previously said, they will produce these gases that will evaporate, and these gases are hydrogen. Okay, now they want the chemical equation. So sodium plus water will give you this plus H2. What is this? The missing element here, or the missing compound is the metal plus hydroxide. So what's the metal in this case? It's sodium, which is Na, and hydroxide, which is OH. So here it's NaOH. Okay, now that we have this equation, we should balance it. We have Na here is 1, H here is 2, O is 1, Na is 1, O is 1, H is 1 plus 2. Let me delete this. 1 plus 2. We multiply this by 1 over 2 to balance it out, so 1 over 2. And then we don't want fractions, so we multiply by 2 everywhere, so this cancels out. 2, 2, 2. Okay? So this is the balance equation. If you have any questions, please ask me. Don't hesitate. Good luck in your exam. Thank you for your attention.